Okay, so we've introduced the knapsack problem, and we understand why we've seen that in the 0-1 knapsack problem, we cannot fractionalize items. So in this video, I really want to analyze, before I get to the recursive approach of solving the problem, why can't we use the greedy approach for this? So let's take an instance where we have a maximum weight of 8. I have items X, Y, Z, and then the weights of the items are 3, 5, and 7. The profits you can make from the items are 4, 7, and 10. So of course, with the greedy approach, you have to do the profits versus weights. So after computing this, I get 1.33, 1.4, 1.43. So pretty much similar to the numbers we had before. I just ignored one item there just to make my life easier. So how do we go about solving this particular problem? So let's look at the greedy approach. So in the greedy approach, I'll choose the item with the highest profit, or the most valuable item here. That's going to be 1.43 here. So the one with the profit per rate of 1.43. So it means I choose the whole of that item. So I'm going to add, so it means like I'm going to include the whole of item Z, which means that my weight reduces from 8 all the way down to 1. So that's going to be the first caveat there. But then the maximum profit I can get from there is 10. Keep in mind, the moment I have a weight of 1, no other item can fit in my knapsack, and we can't fractionalize, so it means I'm done at that particular front there. So I choose the valuable item, and then I only remain with the weight of 1. No other item can fit in my knapsack. The least one here is 3. So it means the maximum profit I can get there is just the one I get from Z, which is 10. So I'm done with that. However, this is not the global optimal solution. That's typical of a greedy approach where you don't guarantee the global optimal solution. Yeah. And so the global optimal solution was, if I chose X and Y, so the weight 3 plus 5 will fit in a maximum weight of 8. But then the maximum profit I would get would also be 4 plus 7 from those particular items, which is 11. And 11 is higher profit than what I got from the greedy approach, which gave me 10. So in this instance, we see that in the fractional knapsack, we can apply the greedy approach, but in the 0-1 knapsack, we cannot apply the greedy approach. And that's why we are going to introduce dynamic programming. And in the next video, we are going to try find the dynamic programming solution, top-down approach for this. So what's the recursive subproblem and how can we make it